Hey guys, today we're going to look at lesson 87, congruent polygons. How we're going to look at this and how it should actually be, how they are going to tell you to do things in your book are going to look a little differently. I just want you to understand the concept of congruent and polygons mainly. So there might be a couple parts to this where we stop and we talk about the back page more. This front page is really what you're going to do is draw shapes that are exactly the same. And that's basically what congruent means, that they're the same. Congruent polygons have all corresponding angles, and the angles are equal to one another on two different shapes, and sides are equal in length. And obviously if the angle is the same, then the shape is the exact same. So an example I have here of that is that I have these note cards. These two note cards are congruent to one another. Their sides are the same length all the way around. I don't know if you can really tell that, but and then their angles are the same. So if I cover one up, I won't see the other at all because they are congruent. They're the exact same size and shape. Here's another card. This card is not congruent to these. If I put them side by side, they're not congruent. There's different angles. If I put a corner together, you can tell the corners don't match up. Maybe this side would work better. But they are not congruent. See there on the bottom? This angle is different than this angle. And that's kind of the concept that you're trying to understand, is that congruent shapes are the exact same. Okay, so there's part one. The next part is important to understand about labeling your congruent shapes. So I have two shapes here. When you're labeling two figures as congruent or the same, the order of the letters is important. When the two figures are traced in letter order, the order of the side lengths and angle measurements must be identical. So here we have two shapes. We have triangle ACB and triangle DEF. Triangle ACB is congruent to DEF, which means this angle here and this angle, or DEF, are congruent. They are not congruent in this picture, but in your picture on the worksheet, they're congruent, okay? So they're focusing on this angle and this angle are the same measurement. If you took a protractor and you measured it, you would get the same angle number, okay? But if I wrote triangle ACB is congruent to triangle EDF, that would not be true because I'm saying this triangle ACB is congruent to EDF. And that's saying this angle is the same as this angle. And in this case, on your worksheet, that's not true. They're different angles. They're different sizes. Okay, I brought the worksheet closer, so hopefully this makes a little more sense. But I have to read off of my book. Hold on. So, in the figures above, notice that the A on the first figure has the same angle markings as the D in the second figure. The same is true with B and E as well as C and F. Also notice how the side markings match in the same direction. This pattern will be true for every instance of congruent polygons. So again, they're just showing you how this side of the triangle is matching this side of the triangle, even though they are in different positions, like geographically, they're on different sides, they're still the same shape. If you took this shape and you overlaid it over this one, it would match up the exact same. So on this page, this is what they want you to do. They showed you two examples of a quadrilateral, and they want you to draw two congruent quadrilaterals as well. You can do that right over here. You're going to do the same thing with the triangle. They gave you one side right here. That's what that's for. So that should be your base. And then you need to find the angle and figure that out. It's easiest to use a protractor while doing that. If you don't have one, that's okay. Just use a ruler and try to make them the same length, okay? Measure 2 inches, draw 2 inches for the line, 2 inches for your congruent line, okay? Try to keep it as similar, congruent as possible. If you have a protractor, you can go ahead and use that. That's fine too. Okay, so that's mostly it for the front page. Again, you're basically just drawing the same shape twice. You just want to make sure that your angles are congruent. Please don't do this. Don't say, okay, my shape is going to be a triangle. Oops. Here's one triangle and here's another triangle. Don't do that, okay? Measure it out. Make sure that you take your ruler. I don't have one right now, but I have my note card. And I'm going to say, okay, my length is going to be the length of this side of my square or whatever. And you draw your square using proper measurements, proper, okay. So all my angles should be congruent. And then if I do another one, it's going to be the exact same. Squares are kind of cheating, I guess, because you are, they're exactly the same. But you could do a triangle and use the same, and then do one that mirrors it even. I don't know, am I off? Oh, no, oh, good. You could do, one that mirrors it. And I used this much for my angle. This is where your protractor would come in. And then right here. So they're not exact, but they're pretty close, all right? So that's what they're looking for when you're doing the angles. Next, I will walk you through the back page because I think it may be a little confusing. So we'll do that next. Okay, so for this part, I'm gonna look at the solve number 3, all right? So Mike is installing paving stones in a circle 4 feet wide around a swimming pool, according to the diagram on the left. How many square feet will be covered with paving stones? Use 3.14 as the value for pi and express your answer to the nearest hundredth. So what you need to do here is find the area of one circle and then the area of the second circle and then subtract those two, basically. So remember, area of a circle is pi r squared. Okay, so that's your formula for that. So to find the area of your big circle, you're going to have A equals pi, radius of my big circle is 12 feet. And that would be 12 feet squared. Sorry, my marker's off. And then my area for my little circle is going to be pi 8 squared. Okay, so that's your formula for that one. And then you will just work out the math. Again, when you get, we'll do this big one together. So I have 12 squared equals 3.14 is my pi times 144. It's 12 squared, 12 times 12 is 144. Pi, again, they said they wanted you to actually solve that. So 3.14 times 1.44 is, oh, they subtracted it first. That makes sense. So you could do that. So 8 squared, 8 times 8 is 64. So then they took 144 minus 64. See that? Okay. And that's 80. So now 80 pi. And so then they took 80 times 3.14. And that is 251.20 square feet. Okay. So you could have done that either way. You could have found the square and multiplied that out and then subtracted, but that kind of makes sense. So we took the radius of the big one and the little one, squared them, subtracted, and then took it times that. The next part says each paving stone is a rectangle that is 9 inches long and 6 inches wide. How many paving stones will Mike need to cover this area? Okay, so you're using this as your area. Oh, I'm sorry, you cannot see that. There you go. So this is your area that needs covered. And then you have your paving stone is where did they go? 9 inches long and 6 wide. So sometimes it's helpful to draw a picture. So if this is 9, this is 6. How many paving stones will he need? If you look at it this way, you're gonna go 9 inches. So how many inches in a foot? 12. So 9 out of 12 is 3/4 of a foot, okay? And then 6 out of 12 is half a foot, right? 1, yeah. So then that is basically, if I say 0.75 and 0.5, because if I convert those to decimals, right, that's what is my area. Well, that's how I'm going to find my area. So I have to take 0.75 times 0.50. Okay, there, I decluttered a little bit. So I'm going to find the area of 1 paving stone, which I said was 0.75 and 0.5, or 3/4 of a foot and half a foot, okay? So 0.75 times 0.50 is 0.3, I lost it, shoot, sorry. 3.75, that's what I thought. Okay, so now this is how much area 1 paving stone is. This is my whole area that I have to cover in paving stone. So I'm gonna then divide that by 0.375, okay? This is the answer from before, when you figured out the area of the big circle minus the little circle in between. So I will take 251.2 divided by 0.375 is 669.86. So that's how many paving stones I need to cover the circle. I can't get half of a paving stone, so you always round up in this case. So this would be 670 stones, okay? So that's that part. Okay, and then this last part asks, if Mike purchases 10% more paving stones than the measurements require, how many paving stones will he purchase? So this is going back to your percentages. I have 670 paving stones, but he always gets 10% more. So I want to basically, what I'm doing is finding out 110% of 760 or 670. Sorry, 670. So how do you do that? Remember, you're going to change this to a decimal. So you have 1.1 and then multiply that times 670. All right. So sorry, you can't really see that. 670 times 1.1. That's your thing there to figure out how many paving stones he's going to get in total. All right. So go ahead and you can try and figure out that last part, that last problem solve on yourself. It's a little bit different. It has fractions, but go ahead and give it a try. We worked through some of those. Hopefully that kind of made sense. Just let me know if you have any questions. See you later.